Classroom Idaho, Learning at Home. The Idaho State Department of Education and Idaho Business for Education is partnering with Idaho Public Television's education team.
I have a question for you. Do bad events always lead to bad effects? I'm Ms. Rood, and today this is the question that we are going to be answering. Let's take a look at our learning target. Our learning target for today is I can determine how real-life events have real effects. Our success criteria is I know I am successful when I find the cause and the effects of a story. Yesterday we learned about cause and effect, and in our practice we learned that cause is something that happens and an effect is what happens as a result of that cause. We came to love the phrase as a result. So we saw that cause, something happens, as a result something else happened. And we saw that in our fictional story with Bear and the donkey egg. Today, we are going to be looking at cause and effect in the real world. We're going to look at some examples of real life cause and effect. We'll read some paragraphs together and identify the cause and the effect. Our first one says, in Queensland, Australia, koalas have been disappearing. Car accidents were one of the main causes, the government said. So it sounds like the effect, what was happening, is that koalas were disappearing. This is our effect. And it looks like the article already gave us a clue to what the cause is. They said that car accidents were one of the main causes. Our cause were car accidents, and the effect, koalas have been disappearing. Well, that's a really sad cause and effect. I hope our next one is a little happier. All right, our next one says, they learned that a popcorn kernel has to get very hot before it pops. In fact, it has to be boiling hot. As the kernel heats up, water inside it boils. It turns to steam. The steam inside the kernel builds and builds. The kernel's hole stretches to make room for the steam. Finally, it cannot take any more. The hole cracks. Well, it sounds like we're talking about popcorn popping. They said that there's something that has to happen in order for the popcorn to pop. It sounded like the kernel has to get very hot before it pops. That's our cause. It has to get very hot. They even said it was boiling hot. Our effect is that the steam builds up, the kernel hole stretches, and finally the hole cracks and it turns into that lovely fluffy white popcorn. Let's look at our next one. It says yawning can also be contagious. This means it can spread from one person to another. When someone sees another person yawning, they might yawn too. This is called contagious yawning. It is normal. Well, it talks about yawning spreading from person to person. That seems to be my effect. The cause is when someone sees another person yawning. As a result, they might yawn too. The weather was unusually warm and wet in these places. This perfect weather helped the butterflies grow. There were more caterpillars. The caterpillars were able to make cocoons. Eventually, they became healthy butterflies. The number of monarch butterflies went up. They are orange and black colored butterflies. Monarchs migrate from Canada to Mexico every year. From 2018 to 2019, the number of monarchs more than doubled. Something similar happened in the UK. The marbled white butterfly population grew by more than half. These butterflies are white and black covered. It sounds like in this article, we are reading about how the number of butterflies went up. And the thing that caused that was that the weather was unusually warm, which meant that there were more caterpillars and therefore more butterflies. Let's look at our last one. Claire Simon is a veterinarian. She runs the seal hospital in Hawaii. Last week, she was about to eat her lunch when her cell phone rang. The call was from the seal hospital. Simon usually gets calls from work. She answers questions or helps if something goes wrong, she said. This time, when Simon answered her phone, something was different. She did not hear someone asking a seal-related question. Instead, she was met with complete silence. Over the next 15 minutes, Simon's phone rang 9 times. Each call was the same. They were all from the same number and all totally silent. Simon thought something terrible had happened to one of the seals. She quickly raced back to the hospital. She arrived and expected to see people running around. Instead, she found everyone sitting outside. They were eating their lunches, completely calm. Finally, she entered the hospital's lab, and there was the answer. There is a gecko sitting on the touchscreen of the phone, she posted online. She added it was making calls with his tiny gecko feet. The gecko had called her 15 times. All right, so we have our effect that she was getting calls and no one was on the line. She kept getting these calls and it was totally silent. And the cause of these calls, a little gecko sitting on the phone. Yesterday, we looked at cause and effect in a very much not true story. And today, we just looked at different examples of cause and effect in real life. And we saw that it works the same way as in pretend stories that it does in real life. Now, what we're going to do is take a look at it in a book that is a true story. I gave you a question at the very beginning. And it was, do bad events always lead to bad effects? We're going to be looking at a real life cause and its real life effects. Before we do, we need to review some things so we're prepared to really dive into this story. The first thing we're going to look at is our new genre. We are reading a biography today. A biography is a book written about a real person. It could be a person from the past or it could be a person from the present. In this case, this person is still alive today. If the person is real, that means our setting is real. So we should probably figure out where our setting is. Our setting today is Malawi. Malawi is a country in Africa. So we are going to be reading about a real person in a real country. There's a word in this book that we definitely need to know what it means, and that is the word maize. Maize is what we would call corn. It's another word for corn. So we will see this word a lot. We need to understand that it is the word corn. Now, before we start our story, I want to return back to our essential question for today. Do bad causes always have bad effects? We are going to see one very big bad cause. And I want you to think about what the effects are on the people in the story. Now, there's going to be more than one effect, and there's going to be more than one character that it does affect. So our job today is to look at the effects of this big cause to determine if they're always bad. The book we're reading today is The Boy Who Harnessed the Wind. We are going to be reading the story about William in our very real setting of Malawi. Because our setting is a real place, that also means that the people in it are real people, which means that there are some real words in the language that William speaks. It is not a language that I speak. I am going to try and do my best, but I do apologize if I mispronounce anything. This is The Boy Who Harnessed the Wind. In a small village in Malawi, where people had no money for lights, nightfall came quickly and hurried poor farmers to bed. But for William, the darkness was best for dreaming. He dreamed of building things and taking them apart, like the trucks with bottle-cap wheels parked under his bed, and pieces of radios that he'd crack open and wonder, if I can hear the music, then where's the band? His grandparents' tales of magic also whispered in the pitch black of his room. Witch planes passed through the window while ghost dancers twirled around the room, as if 100 men were inside their bodies. At dawn in the fields, William scanned the maize rows for magical beings, then wondered as a truck rumbled past, how does its engine make it go? Pay attention to where you throw that hoe, his father shouted. You'll cut off your foot. For all its power over dancers and flying things, magic could not bring the rain. Without water, the sun rose angry each morning and scorched the fields, turning the maize into dust. Without food, Malawi began to starve. So here's our big cause. Let's take a look at the effects. Soon William's father gathered the children and said, from now on, we eat only one meal per day. Make it last. In the evenings, they sat around the lantern and ate their handful, watching hungry people pass like spirits along the road. Money also disappeared with the rain. Papani, his father said, I'm sorry. You will have to drop out of school. Now William stood on the road and watched the lucky students pass alone with the monster in his belly and the lump in his throat. For weeks he sulked under the mango tree until he remembered the library down the road, a gift from the Americans. He found science books filled with brilliant pictures. With his English dictionary close by, William put together how engines moved those big trucks and how radios pulled their music from the sky. But the greatest picture of all was a machine, taller than the tallest tree, with blades like a fan. A giant pinwheel? Something to catch magic? Slowly, he built the sentence: windmills can produce electricity and pump water. He closed his eyes and saw a windmill outside his home, pulling electricity from the breeze and bringing light to the dark valley. He saw the machine drawing cool water from the ground, sending it gushing through the thirsty fields, turning the maize tall and green, even when farmers' prayers for rain went unanswered. This windmill was more than a machine. It was a weapon to fight hunger. I love that sentence. It's such a powerful sentence. It was a weapon to fight hunger. "Migetsi on Mepepo," he whispered. "I will build electric wind." In the junkyard, pieces appeared, like rusted treasures in the tall grass. A tractor fan, some pipe, bearings and bolts that required every muscle to remove. "Tonga!" he'd shout to the birds and spiders, holding up his prize. But as William dragged his metal home, people called out to him, "This boy is Masala. Only crazy people play with trash." After many weeks, William arranged his piece in the dirt: a broken bicycle, rusted bottle caps, and plastic pipe, even a small generator that powered a headlight on a bike. For 3 days, he bolted, banged, and tinkered while chickens squawked and dogs barked, and neighbors shook their heads saying, "What's Masala doing now?" His cousin Geoffrey and best friend Gilbert soon appeared. "Muli Buanji," they greeted. "Can we help with electric wind?" "Grab your pangas and follow me," he said, and took them into the forest. Together they swung their sharp blades into the trunks of blue gum trees, then hammered them together to make the tower. "Stand atop," William shouted. "Bring it up." While the boys tugged and heaved, a crowd gathered below and gazed at this strange machine that now leaned and wobbled like a clumsy giraffe. Some giggled, others teased, but William waited for the wind. Like always, it came. First a breeze, then a gusting gale. The tower swayed and the blades spun round. With sore hands once slowed by hunger and darkness, William connected wires to a small bowl, which flickered at first, then surged as bright as the sun. "Tonga," he shouted, "I have made electric wind." "Wachita bueno," a man yelled. "Well done." As the doubters clapped and cheered, William knew he had just begun. Light could not fill empty bellies, but another windmill could soak the dry ground, creating food where once there was none. "Magetsi a Mepepo," electric wind, "can feed my country," William thought. And that was the strongest magic of all. Now, in the book, we saw the really big cause, and that was that there was no rain. I'm going to add that to my flow map. Now, typically with a flow map, we do it in a nice, neat order of cause, as a result, effect, just like we did yesterday. But today we have quite a few effects of no rain. So my flow map is going to look a little crooked, and it might have a couple of offshoots. And that's okay, because the map is here to help me organize my thinking. So the first thing we saw with no rain is that the maize dried up, the corn dried up. So there was no maize. What else did we see as a result of no maize? That's right, we're going to have an effect of an effect. As a result of no maize, there was not enough food. As a result, there was not enough food. So returning to my essential question, we have our cause here with our effects. And so far, a bad cause only has bad effects. One of the effects of no rain was there was not enough money. The maize dried up and they weren't able to sell it. So his father said that he wouldn't be able to go to school anymore. So looking at this, an effect is William could not go to school. So far we have another not so good effect. However, I do remember something that happened after this. As a result, William went to the library. And what did he find in the library? He found a windmill. So William could not go to school, which means he went to the library. Squish that word in. And as a result of that, we're going to come all the way down here. William learned about windmills. So already we're seeing that this cause right here has a whole lot of effects. So already we're seeing that this cause right here has many different effects, and our effects have effects. We have this chain reaction of things that are happening. And this continues. When William learned about the windmill, what did he do? He started to build one. And after he built one, as a result, he was able to bring electricity and eventually water to his village. Thank you so much for reading a biography with me today. and looking at the cause and effect of some really bad events. Also, thank you for helping me with my really crazy flow map today. Let's go ahead and take a look at our learning target to see if we were successful. Our learning target today was I can determine how real life events have real effects. Our success criteria was we knew we were successful when we found the cause and the effects in a story. Well, we looked at the real events like the koalas and the gecko calling on the cell phone and the butterflies, and we found the cause and the effects in those articles. And then we also looked at a biography, which was a real person and real events. And we looked at the cause and the events. There were a lot of different events. So I would say that, yes, we were successful today. This is our last time reading together, but that doesn't mean your learning stops here. You are more than welcome to continue looking at different biographies of different people and looking at the cause and effects in their life. And keep exploring the question, do bad events always have bad effects? Don't be afraid to draw your own crazy flow map as well. I'm Ms. Rood, and thank you so much for reading with me. Want to continue working on our learning target at home? Here are a few things that you can do on your own. You can read real life events and find the cause and effects. Some examples of places you can find them
Read some biographies,
newspapers,
nonfiction books,
causes and
magazines
effects in their lives. You're welcome to make your own crazy flow map just like we did today. Finally, look at your own life. What are some big events that have happened to you in the past? What are some little causes and effects that you see every day? Write them down, make a flow map, and think about how cause and effect is around us all the time. Thank goodness you are here. I really need your help this time. You see, my sisters are coming over for dinner, and that's a huge problem. I love my sisters, and I'm so excited to get to see them, but cooking for them is really hard. Ever since we were kids, we need to make sure that all of our pieces are the same. They have to be equal. And even though we are adults now, it's still the case. So I need your help making sure that every single piece is all equal and the same so there is no fighting at this dinner. I'm Ms. Rood, and today we're talking about fractions. Let's check out our learning target for today.
Our learning target for today is I can create fractions. Our success criteria. I know I am successful when I partition a shape into equal pieces.
Let's talk about fractions. Fractions are equal parts of a whole. When we partition a whole or cut it up, we are making equal parts, and that is our fraction. Today, we are going to be partitioning whole foods and looking at the different fractions that we create. When I say a fraction, I often see two parts, a top part and a bottom part. Our bottom part is called a denominator, and our denominator is how many equal pieces are the same as one whole. Our numerator, which is up top, tells us how many of those pieces we are talking about in that situation. Today we are going to partition the food that we will be eating to make sure that we have equal pieces for me and my sisters to eat. First up, it's going to be our fruit dish appetizer.
The first thing we need to do is prepare our fruit dishes. Part of that is our oranges. So I have an orange here that I'm going to peel. And I'm left with one whole orange. We need to partition or cut the orange into equal pieces. Now, luckily for us, oranges kind of do that for us. So I just partitioned this orange into two halves. One half, two halves. There are two equal pieces that compose one whole. Now I'm going to partition this orange even more. My orange is now partitioned into 8 equal pieces. If I was to write this as a fraction, my denominator would be 8 because that is how many of these pieces I need to compose one whole. So if I were to count how many eighths I have, I would say 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. Well, I think this orange is ready to go into our fruit plate because they are all equal partitions. Next on our fruit plate is the banana. Now, unlike the orange, our banana does not come pre-partitioned, so we're going to have to do that ourselves. My first step, I'm going to peel this banana. And I am going to start partitioning. Now, I want to make sure that my groups are equal. I usually like to start with 1/2. So I'm going to go right into the middle, making sure that this side is as close to this side in size as I can. So I'm going to partition it right here. I now have 2 equal pieces, or 2 halves. I now have 2 equal pieces, or 2 halves. Well, I have more than 2 people coming for dinner, so, well, I'm going to have more than 2 people eating dinner, so I should partition a little bit more. What I'm going to do is go right in the middle of this half and cut my half in half, and come in the middle of this one and cut my half in half. And now I have 4 equal partitions. We would call these fourths. There are 4 fourths to compose one whole. These are still pretty big pieces. I think I'm going to partition a little bit more. So once again, I'm going to cut in half here. Cut this one right here. Let's partition right here. I'm trying to make these as equivalent, as equal as possible. All right, still the same banana, still the same hole, but now I have 8 partitions to equal one whole. That's 8 eighths compose one whole. Pieces are still a little too big for me, so I'm going to keep partitioning. We're going to slice like this, being as careful as I can to make sure that they are the same. Whew, that one's a little bit bigger than that one. We're going to pretend they're the same. There. Let's partition this one right here. We're going to partition this one right here. Okay. It's kind of hard to make them stand up, but they're still equal partitions. So if some flop and some stay the same, it is still the same whole banana. So we have now partitioned this into 16ths. There are 16 equal pieces to compose one whole. How we would count them is 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16, 9/16, 10/16, 11/16, 12/16, 13/16, 14/16, 15/16, and 16/16. I really like that word 16ths, throwing that TH on the end. It's really fun to say. Now it looks like our bananas are in a perfect eating size. We are going to move on to the next item on our appetizer tray. Next on our appetizer tray, we have graham crackers. Now, luckily for us, graham crackers come pre-partitioned. So let's take a look at this. We have a partition right here, and we have a partition right here, which means that if I broke this apart, we would have 4 equal partitions, or fourths. Now it's interesting though, if I do this, it looks like I have halves, but I also still have fourths. I'm a little confused, so let's double check. Okay, I have 1 equal partition, 2 equal partitions. So that would be 2 halves. But I also still see that I have 1/4 2/4, 3/4, and 4/4. So it looks like 1/2 is the same as 2/4, or 1/2 is equivalent to 2/4. All right, well, these are not nearly enough graham crackers for us to dip into our delicious dip. So I'm going to need a few more graham crackers at dinner. Okay, I have partitioned off a few more graham crackers for us to enjoy. Let's count how many fourths I have. Remembering our graham crackers were divided into 4 equal partitions. Let's count how many fourths I have. 1/4, 2/4, 3/4, 4/4. Oh no, I don't know what to do next. 4/4 is 1 whole, but these are still fourths. Can I keep going? Wouldn't this be 5/4, 6/4, 7/4, 8/4, 9/4? Even though they are greater than 1 whole, they are still fourths. There was 1 whole partitioned into 4 equal pieces, and now I just added more of those pieces from the same whole. And I feel like that's enough graham crackers. And that's definitely enough for our appetizer fruit and dip plate. So at this point, I think it's time for us to move on to our main course. All right, it's time for our main course, which is pizza. Oh, I'm so excited. But I need to make sure that this is partitioned into perfectly even pieces, or we're going to fight. Okay, so my first step, I'm going to partition this in half. So using my muscles, I'm going to partition this into 2 equal pieces. I have 1/2 and 2 halves. Well, that's not enough for us. Let's partition this again. I'm going to rotate it a little bit to get a better angle. Now I'm going to partition my halves into halves. And by doing that, I will get 4 equal pieces. Also known as fourths. I have partitioned this pizza into 4 equal pieces. Those pieces still look a little big for us. I think I need to partition them again. So I am going to partition my pizza into 8ths, 8 equal pieces. I'm going to do that by cutting my fourths in half. So I'm going to rotate it a little bit just for a better angle for me to cut. Right, let's take a look at our pizza. I have 1, 2, 3, 4, 5, 6, 7, 8 equal partitions. All right, let's take a look at our pizza. I have 1, 2, 3, 4, 5, 6, 7, 8 equal partitions. Those seem like perfect pizza slices. I think we're good on partitioning there. I think if I partitioned any more, it'd be too small. All right, it looks like it's time to move on to dessert. All right, it's dessert time. Whew, these brownies look delicious. I'm going to shake things up, and I'm going to start by cutting these brownies into thirds, 3 equal partitions. So I am going to cut these brownies into 3 equal sizes, or as equal as I can get. Well, those pieces are way too big for all of us to eat. So I am going to partition these into sixths. I'm going to cut my thirds in half to create sixths. 6 equal partitions to compose one whole. As much as I love brownies, those are still a little too big for me, so I think I am going to partition them again. I'm going to cut these in half. Let's count how many equal partitions we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Twelfths, as equal as I can get them. Still a little too big. I think one more partition might do it. So I'm going to cut these like this. I have no idea how many equal pieces I have. Let me count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 equal partitions, or 24ths. Well, I think those are most definitely the correct size. You know what? These look so good. I think I might have one before my sisters get here. Uh-oh. You know how I said I was going to just have one? Yeah. I ate 3. So if I was going to write this as a fraction, that means I ate 3 of the 24 equal pieces. Well, that means that there are 21 24ths left. Oh, that should be enough for my sisters. Oh, good. Okay, my sisters are going to be here any minute. Let's just double check to make sure that everything is into equal partitions. It looks like the pizza, everything is equal there. The brownies, we have equal pieces there. All the fruit and the graham crackers, yep, they all look like they are equal partitions. Whew, this should work. We still have time before they get here to review our learning target. Our learning target today was to create fractions. And we knew we were successful when we partitioned a shape into equal pieces. Well, we partitioned a banana, the orange, graham crackers, pizza, and brownies all into equal pieces. So I would say that we definitely met this success criteria and were successful in our learning target.
Thank you so much for your help today. This has been a great way to spend our last math time together. Remember, your learning doesn't have to stop here. You're welcome to practice fractions and partitioning at your home with your own food, making sure all of the pieces are equal. I'm Ms. Rood, and thank you so much for being here and doing math with me.
Want to continue practicing our learning target from home? Here are a few things that you can do. You can partition your own food into equal pieces with your grown-up permission, of course. Find other things you can safely partition. Practice drawing rectangles and partition them into equal pieces. This is especially good if you are not able to partition real things. Practice counting by fractions. What happens when you count greater than one whole? Kind of like what we did with our graham crackers. I've had so much fun this week getting to learn with you. Here's a reminder about the things that we learned about for you to practice at home. In reading, we found the mood in illustrations. We changed adjectives to make a new story. We compared and contrasted two different books. We found the cause and effect of events in books that were both fiction and nonfiction. We looked at cause and effect in real life. In math, we iterated equal groups. We drew those iterations into arrays to make a more organized model. We used arrays to decompose tough multiplication facts. We got tired of drawing arrays, so then we learned to skip count efficiently with ratio tables. And finally, we partitioned into equal pieces to make fractions.
Funding for Classroom Idaho has been provided by the Friends of Idaho Public Television, the Idaho Public Television Endowment, and the Corporation for Public Broadcasting.
You're watching Idaho Public Television's Create channel.